Hey, hello, and welcome to the show. It's me, John Park, and I'm messing around with the controls here and restarting the song. I don't know what's actually being said there, Mouse. It was a sample off of, I think, an Alexa wand thing. It was like a barcode scanning Alexa with a magnet in it, and I think I sampled that and then pitched it way down. I think that's what that was. I bet, you know what? I may still have the file on the black box sitting right here on this doohickey. Do I have it plugged in a way I can lift it? I made that song on this gizmo. There's a chance. Maybe later we can check and see. I bet we can find that sample. All right. There's the bonus challenge today. Thanks for asking. So what's happening here? This is the chat, by the way. Who am I talking to? Well, I'm talking to people over in our YouTube chat as well as our Discord chat. So if you're somewhere that doesn't seem to have a chat, go there. How do you go there? Go to adafruit.it/Discord. Look for a live broadcast chat channel. And hello to Mouse for stopping by and for asking about that sample. Johnny Bergdahl, some nice hello. Andy Calloway, Thin Man, Blitz City DIY, Paul Cutler, hello. Thank you all for popping in. Over in our YouTube chat, we've got Dave Odessa, Connor McCarter, Bergraf Avdalhagen, Johnny Bergdahl there as well. Thank you for popping in. So what's going on here? We've got, this is the show, this is my workshop. What am I doing? Let me move that out of the way. I am gonna give you a discount code. I'm gonna show you a recap of the product pick of the week. I'm going to do a CircuitPython Parsec. I've got project build. So last week we were looking at the Knobby Sequencer, and I designed a little case for it last night, and we'll take a look at assembling that. Some ideas on extensibility and modularity with that. And what else? This is the show. This is not the live broadcast chat channel. Todd, I love the icons. It really sells it. I could go for a big soft pretzel, couldn't you? So let's get it going. Hey, hello, Beef Wellington. Also joined the chat over on YouTube. Hello. Well. So first of all, I'll say, if you want to go buy some stuff at Adafruit's shop, then that coupon code right there is the way to go. Look, it looks like almost like a t-shirt. There's my coupon code t-shirt. Don't move. Smiley in beautiful teal will get you 10% off in the Adafruit shop today. So you can head over here. That's the Adafruit shop. Let me move this out of the way. Go right there. Just go to adafruit.com. That automatically transports you to the shop. It's the front page. And if you want to see what's new, you've got a little banner area here, new products, view all new products. Just click on that. Here's some new stuff, and you can save some money on it. Here's a pretty nice looking magnetic angle sensor. I'm interested in this. So this is the AS5600 magnetic angle sensor. I'll probably do that maybe in a month or two as a product pick of the week. So, you know, you might want to keep that in mind. But this is a nice way of measuring rotation, particularly for things like knobs on bearings that can spin freely and have no mechanical parts to wear out. Kind of a neat, I think maybe Liz is going to work on a project like that. I don't want to put words, I don't want to put projects in your mouth, Liz, sorry. But I thought maybe that was something. Or maybe No Way was going to, someone said they might take a look at doing a little endless encoder type of thing with a magnet sensor. We've got some new chips for a couple of the e-ink products. So one of them is in stock, the other's not yet, but the e-ink breakout with this SSD 1680 chipset, and then there's also going to be a Featherwing with a similar display and chipset. But any of these things, if it's something we can put in a bag or a box or an envelope and have transported to you, we won't do the transporting ourselves in most cases, but have it transported to you, then you can save 10% just by keeping this coupon code in mind on your way out. Just type that into the coupon code slot, 10% right off. I say it works on things that we can ship to you because it does not work on conceptual things like gift certificates, subscriptions, or software. But if there's atoms, then go for it. And the other thing is, not only can you save 10% by keeping that coupon code in mind, but you can also get some free stuff. If you go to adafruit.com/free, $99 or more, you get a free coaster. $149 or more, you get the coaster and a KB2040. $199 or more, you get the free UPS ground shipping as well as the coaster and the KB2040. Those are all freebies you can get, and you can still get 10% off on your order. I've never confirmed that, but no one's told me otherwise, so I think that all works. Try it, let me know. All right, that's coupon code. That's stuff, that's free stuff. Sip of water time. Next up, let's talk about Tuesday. Going back in time a little bit. Tuesday, I have my product pick of the week show. It looks like that. This week was this cool GPS Featherwing. Here's a little recap. The ultimate GPS Featherwing got the fix LED blinking, and that's because it hasn't found any satellites to fix to because I'm inside. Grab this. I'm going to walk away for a second. I'm just going to hold it at the sky. So I've picked up 4 satellites, 5. We've picked up the number of satellites. It's down to 3. Holding on to the last latitude and longitude. I've reduced the accuracy of that just so that it's not an exact pointer at my workshop. Fixed timestamp, that's when it actually grabbed onto those satellites. Latitude, longitude, which I've reduced the accuracy on. Fixed quality, the number of satellites, which were 4 when I plugged this in. Altitude, speed, track angle, horizontal dilution. These are all some of the details that you can grab right off of the satellites using this code up here in the CircuitPython libraries. Ultimate GPS Featherwing. It's the ultimate. And I didn't say that in the recap. I did mention it on the live stream, and we just had a little confirmation on the Discord from Brent. Brent says, I'm working with the GPS Featherwing as we speak. I mentioned, Brent said that they are integrating the GPS Featherwing into Whippersnapper, so there will be some drag and drop codeless integration, so you can add GPS information to your Adafruit IO projects and QTT projects, all without coding, which is super cool. Looking forward to, maybe you can bring that on Show and Tell next week or the following week, depending on where that's at. We'd love to see more, Brent. All right. What else? Let's get into a CircuitPython Parsec.
CircuitPython
Okay, that's not the right screen. That's it. Are we ready to go with this? Yeah, okay. Let me arrange my little screen there. Hey, for the CircuitPython Parsec today, I wanted to talk about adjusting the scale of display I/O objects using the .scale property. What you see right here is a little OLED screen. I just have it vertically oriented. It's plugged into a Feather RP2040 Feather over I2C. So it's a little I2C OLED. And I have a little emoji, emoticon, ASCII type. It's a colon and it's a parenthesis. I don't remember what we call those anymore, but it's a smiley face. And the way I'm creating that is using text. I have a text object called label here that's using the terminal IO font in a white, this is a black and white OLED, with a size that I've set, a position that I've set previously. So very similar to last week where we're moving these around. But right now, instead of moving around, I just want to adjust the size of it. Now, there are a couple of ways to do this with fonts. You may have multiple fonts. If it's bitmap, if it's terminal IO, it has built-in scaling. However, what I'm showing can work for a lot of different types of objects, including groups, I believe. And in this case, I'm just going to use it on that label, but this is something more than just fonts, so you know. To set the scale of it, I'm simply saying name of the object, text area, .scale equals, say 1, and there's the sort of default size. Let's make it 3 times bigger. I'll just simply say text area.scale equals 3. So this works with integers. There's not partial, decimal, fractional pieces of scaling. It's just an integer scaling. But it's nice and responsive. So if you take a look at, let's start this back out at 1, and I'm going to uncomment, or rather I'll comment this little pass so that we can now run through scale as we're moving around the screen. You can see on every sort of iteration of this little bounce thing, I'm going to bump that scale up, and we'll go up to, I think, scale 5 or 6 that I have on here. You can see this is I2C, so it's not super fast refresh, so it's starting to do a little bit of bouncy, sheary kind of stuff. But that is all done by simply iterating this text area.scale each time through, and then to make it smaller as we're going back, we're just going from 6 down, stopping at 1. So that is how you can adjust the size of a display I/O object inside of CircuitPython using the scale property. And that is your CircuitPython Parsec. Wow, 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 wow. Alrighty, let me go back to the screen here. So let's see, next thing I want to do, and please don't let me forget, mouse, don't let me forget, a little, maybe after this section, but a little later in the show, I definitely want to try to hunt for the theme song on my black box. Hopefully it's still on there. It saves projects and samples to different SD cards, so hopefully that's the SD card I was using when I created that song. But first, before I do that, I would like to do a little bit of a Learn Guide recap. So let's go to learn.adafruit.com right here, and let's check out this Sparkle Motion Dance Shoes Guide. So first thing is I put together, I can play it here. I don't know if yeah, you should be able to hear it. Might not be too loud, it's just going to pick up over my lav. All right, you get the idea there. So I included a video of some sound sync, and that is using frequency FFT analysis. So you'll notice that it's not just the beat, but it's also sort of the timbre and pitch of things that it's hearing in the sound. Allows for some really neat effects there, all using WLED. So these are the dance shoes, platform shoes, and there's a couple other videos and demos of them in there. The guide is live. You can go check it out now. You can, of course, also extend some of these ideas for other wearable WLED, NeoPixel types of projects. This has 2 synced boards. You can extend that to more, but I've got 2 synced boards. I've got a sort of easy mode and advanced mode on the build. So if you check out the simple build here, this one is, I believe, no solder. If you can get, I don't know if we're released these yet, if you can get the Sparkle Motion Mini with the terminal block header already soldered on it, then it's just cutting some wires, stripping them, screwing them into the screw terminals, plugging in a battery, and you're set. So steps that I go through here in the guide, let me make this just a little wider here, a little bigger. I've got a little foam liner in there, sorry about my white balance, a little foam liner in there for just keeping things from rattling around. Just made some craft foam. And then I'm using one of these very particular batteries that has a shape that fits perfectly inside of this type of shoe. On the first page in the parts section, there's a link to this shoe. You can buy it from different places, but that'll tell you what you're looking for. And a very, very svelte little USB-C cable right there. This is my new best friend, this cable right here. So I've got a link to that. I believe Lady Ada is going to look to see if we can stock these in the shop, so you might be able to get them through us. But I've got a link, and I think this is the 150 millimeter length, which works really well in this project. They also have a 75, little short one that might work for other types of projects. And so I'm just using a little bit of adhesive to secure that battery inside the back of the shoe, and it's a little bit like building a ship in the bottle. So I put the battery in first, and then we start feeding in the LED strand, and then also attaching the Sparkle Motion inside of the sort of trap door that opens. When you want to turn it on, plug it in. When you want to charge it, unplug it, plug in a charging cable. So that is what that looks like, and there's one of those. Actually, this is the 2 different styles here. I think the one on the right here is that one. If you go to this Advanced Treasure Shoes circuit, in this one I've added a little more complexity, but a little more versatility. So we have still the Sparkle Motion Mini. We have NeoPixels plugged into it, of course. I've got a Power Boost 1000C, which is a charger and a boost converter to take 3.7 volts-ish off of your LiPo and give you the clean 5 volts out to the Sparkle Motion Mini. And I'm also using one of our little breakouts to keep the wiring really, really compact. And I've also run a USB-C input for charging up to the tongue, or the insole really of the shoe, the trapdoor, and an on-off switch that's available for enable, disable pin on the Power Boost. Got some 3D printed cases that I've just modified from one of the Ruiz Brothers ones and posted there, and I also made a little case for the Power Boost, show wiring that all up. And so you can see here kind of a nice extension to your Power Boost enable pins, as well as the power. So we're just using 3 wires there to cover ground, enable, power. And then you go back here, we assemble that into the shoe. This one's even more of a ship in a bottle here. I've got sort of a little stack of battery, Power Boost, and the Sparkle Motion with little adhesive strips, those U-glue strips in them. Press that down. I use some tweezers. I don't know if I showed them in these photos. I think I did somewhere. There you can see the ends of them. Use some long tweezers to just push those. Some chopsticks or something would work as well. And then again, we just feed in the LEDs. In this case, I'm using, oh, I've got the same ones in here. Okay, I've got a couple of versions of these going there. But yeah, there you can see it. That one's the little star LEDs, and there they are in action. Couple questions from the chat about, Mouse said, how do you do FFT? It is built into the WLED software, and we have a digital PDM microphone built onto the Sparkle Motion. So in the WLED settings, which I can show here, Under, I believe, additional settings, I've got setting this up as an access point. Actually, this is a mirror from one of Aaron's articles on WLED, or guides on WLED. Configs, so you can save a little JSON file that's the configuration, and that's really helpful. When you set up one, you can copy that and paste it onto other subsequent boards, so you're not just using a UI to change everything. So I got LED preferences, sync preferences, so that the two boards can sync with each other. And let's see, where do I show? I think the audio reactive might, is it in here? No. Oh, I might have just run past it here. Let's see. Config, sync, user mod. Yes, so in the user mod section, we've got audio reactive, and you can enable it, tell it to add palettes. There are color palettes that go along with audio reactive. And then for this particular board, and this is different for almost every board you could use. If you were doing this on a Cutiepie, you'd have different pins involved, different microphones involved. But we've got a digital microphone. It's this SPH0654. It is on, again, it's hardwired, built onto the board, so you're not rewiring this. It's got the I2S SD pin 9, word select on 10, SCK 23, and it doesn't use the M clock. You can adjust this little config section down at the bottom for tuning it to the sound environment you're in. And this was actually Lamore's suggestion, this vivid automatic gain compensation, I think might be what AGC is. That one worked particularly well for this type of music application for this. It does also work for impact, so just walking in these shoes will, in most cases, cause the FFT to light up somehow. But you really want to tune this up for the music that you're listening to. That, by the way, is a Bartle Beats song that I was playing there, and the Bartle Beats record that I had on the turntable. Although it's a bit of fake out, that is not a Bartle Beats song on that record, so I was playing something else at first, but the music that the shoes were listening to was coming off of Bluetooth and was accurate. I'm not lying entirely, but I just wanted to have the vinyl record graphic happening. And that is it. So that's the shoes put together. I'm going to get the shoes to my drag artist friend hopefully next week and get some action footage of those and some better video and photography. But if you want to go check out the guide now, it's live, and you can build those or something like those using that info. All right, let's see. Next up, I want to see about this here intro song. Let's grab the black box here and let me refocus. So this is one of my favorite little bits of gear. It's essentially a sample station in a box, no computer necessary. You can sample into it. You can have samples put on an SD card, and then you can play them in little pads. I'll turn up some sound here. And you can arrange them into loops and songs using sequences. Here's a little sequencer. How do I enter? Yeah, there. So there's a little sequencer. Oh, that's what I've got playing right now. There we go. Woo! All right. And what I wanted to do is go to presets and see if I can find. Actually, let's just see if we can load that sample in. Where would you be? JP samples. Alexa wand. Get ready. Hopefully you can hear this. Oh, that's not it. Here we go.
I'm having trouble understanding right now.
I think that's it. That's just that piece right there. Let's see, can I can slice the sample or edit the sample length a little bit. Let's bring this in. Here we go.
I'm having trouble understanding right now.
So now that that's, I loaded that, right?
I'm having trouble understanding right now.
So I'll make that a little louder.
I'm having trouble understanding right now.
So that'll play the sample back as is, but the very cool thing is that you can repitch on the fly.
I'm having trouble understanding right now. I'm having trouble understanding right now.
I'm having trouble understanding right now.
So something like that is what you're hearing in the voice that's in my intro song there. Let's see, can we find the song? What's the project called? Not great search. I'm going to start at the bottom and work my, oh gosh, I have a lot on here. Turtle JP? Probably not. Sinlow? Is that it? Nope. Stylo? Nope. Let's go back to the top. Alexa Wand, maybe? Nope. You would have thought, but no. What did I call the thing? Chaff. It's chaff. Okay. This is promising. That sounds wrong. Loop it. Yeah, I don't know what's going on with that, but that should be it. Nothing else called chaff? Huh, I wonder why I named it that if that wasn't it. Oh well. But that's like a little peek into the behind the scenes. Sorry, that was quite at least 3-4 years ago, I think now. So I don't have a lot of memories of that. Anyway, that's what's happening. It's an Alexa wand. I think I recycled the wand. It ended up not being something I really needed in my life. Okay, but that will, thank you, Mouse, for asking. That will serve as a, go figure go, and YouTube said, and everyone's Alexa went off. Sorry. You're very welcome. Okay, but I think we'll use that as a bit of a segue into this over here. Let's go to the workbench. Pile of stuff, pile of parts. Let me put myself over in the corner there. Let me grab my phone and put it into the Discord so I can see what's happening. There we go. And let's talk about this little MIDI sequencer, the Knobby Sequencer. In fact, I was demoing it the other day on that black box, and maybe we will today if I get this thing kind of fully built again. I'll just zoom out a teeny bit, and let me try to refocus. That should be good. So what do we have? I put together this little idea of a knob-based sequencer that uses these little encoders. We have 4 encoders per board, and this uses a little little seesaw chip that reads the encoders, rotation, reads the encoders, button presses, and also has the option to write out to these little neopixels. There's 4 of them underneath. Let me get closer actually for a moment. And so it'll write out to from your microcontroller. All that over I2C. The nice thing is that it is pretty efficient at gathering up the positions and button presses and then sending out a bulk reading, a sort of single message, so that we're not polling these things all the time from the microcontroller, which normally is no problem, but when you're trying to do time-synced stuff like music sequencing, it'll get really sloppy really fast or just slow if you're polling stuff too frequently. So I have this set up so that every 4 notes, so to back up a second, this is a sequencer. It counts 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, plays out a MIDI message, which then is plugged into a synthesizer on your computer, or in that case, my little black box sample station. And we can adjust the pitches with the knobs. And we can adjust if we play a note or not by clicking the little press encoder, so that'll mute or unmute a note or a step. And to keep an eye on this, we've got a little NeoPixel strip underneath it. And that, I actually have it lined up. Every third NeoPixel lines up with the center of a encoder. So I mostly leave a bunch of those blank, and we're just doing every third one. So that's running all off of a little Cutiepie. And the Cutiepie has I2C over stemma QT to the 2 encoder boards, but we could do more. So I think I'm going to do 4 of these total. So I'll do a 16-step sequence, and add on more of these NeoPixel PCBs. And then that's just going over 3 pins, 3 volts, ground, and the MOSI pin. I'm just using it as a digital pin. So that's the circuit. I'm going to keep it, I think, very simple. It could use a display, or it could use some of the unread LEDs as a UI of some kind. It could have modes where, like, triple clicking a button or something during startup allows us to change the tempo. There's a lot you could do. For now, I'm keeping it dead simple. But I wanted to build a case for it. So Lamore suggested I do a laser cut case, which will keep it simple, two-dimensional, and allow me to use some of our nice LED acrylic for this section. I'm going to inlay, I think, a little piece of LED acrylic here, or just use full LED acrylic for the whole top and maybe mask out some of it. However, just to test it out, I 3D printed this. I just 3D printed a 3mm but two-dimensional shape there. So that rests on top, and that'll be an option. If anyone wants to do this as a 3D printed thing, absolutely, the files will be, I'll share both sort of a SVG for laser cutting and an STL for 3D printing. Let's back out again and try to focus a bit. So the way I have this set up, this is the second revision. First revision was this. So I had the encoder, and then I had the Cutiepie off to the side, leaving this kind of blank area, and also meaning that if I want to do a second set, it's going to be different. It's going to look a little different off to the side there. So I decided to move the Cutiepie into the middle and have it live underneath the encoder boards. So let's put it together. That's the best way to understand how this goes. I will start with, let's put down, this is a little 3D printed Cutiepie mount. Come on, focus. I very shallow depth of field. Let me see if I can adjust camera. Nope, I can't from up there. So this is a little mount for Cutiepie. You know, one of the things about Cutiepie, based on the Zhao form factor, no mounting holes. So you can snap this. Rees Brothers design is really great. You can snap the Cutiepie into this and then mount it to something. So let's start with mounting. Let's see, that is going to be like that, like that, like that. Okay, so this will fit right here, and then we'll screw down standoffs for the encoders. So for this, I'm just going to use some of these longer M2.5 screws for everything. I will say the NeoPixel strips are actually M2 holes, but if you're using these nylon screws, you can cajole them into going through and still having enough thread on them for fitting into a nut. So speaking of fitting into a nut, I will screw these in place here. Todd says in the chat, what do you mean the Cutiepie has no mounting holes? It's got 14 of them labeled 5 volt, ground, A1, A2. This is true. If you get M0.1 screws, then I'm sure you can use the solder pads as mounting holes. And I'm just using the nylon, these black nylon M2.5 that we have as a kit in the store so that anyone can grab that and use them. In my final build, I may use some of my little metal laptop screw kit screws because they have really flat heads on them, so they'll be a little lower profile. This is not a super low profile build, however, because of these mounting points for the stemma QT. Unless I go to soldering and sink those into the laser cut thing with some little squares, it's gonna live up high. I think that's okay for this build. I decided to keep it simple that way. So these, I have already screwed some standoffs. You can see them, standoffs into them. So those will go here. I think before I do that, I will pop in the Cutiepie. So I want, I'm sorry, yeah, let's get the just trying to figure out where I want like so. Yeah, that'll work well. Okay, so I just want to arrange my wiring. And now maybe I should, oh, there we go. I was going to say maybe I should have done that before I put it on the board so it flexes a little bit, but that worked. So the PCBs will be mounted here with the holes up, and they'll go into this, living under there. And then eventually I'll put in a little diffuser strip there. I decided not to do holes for just those every third NeoPixels because I actually have a little boot up sequence that shows all of the lights light up yellow while I'm sending a MIDI panic message. So this kind of, you know, the LEDs are there, I might as well use them. Let's see how well this fits on there. I think it fits pretty well. This is the first time I'm assembling this since printing this one. Hopefully, my concern is these standoffs have enough clearance with the bracket there, and it looks like they do. Okay. I didn't measure that super precisely when I was putting the CAD together. I will show you the 3D model that I built for this in Rhino. Thankfully, there are Ruiz Brothers models for everything, including the encoder board, the Cutiepie, the NeoPixel strip. All these exist as 3D models, so it's easy to, I trust those models, and it's easy to integrate them into the design base measurements off of those instead of getting out the calipers. Okay, so these, I think I can just do like a so. And these are sort of the medium, like 6mm M2.5 screws. Just put 2 of those in for a second. I might curl that wire a little bit just so that it gets out of the way. Make sure the orientation is correct, or you'll be chasing the sequence backwards and forward like a Larson scanner. Also, by the way, I can't remember if I mentioned this last week, but the NeoPixels that are built into these encoder seesaw stemma QT boards, they work great, but you can't see them in this case. Liz did a cool thing on risers. She elongated the encoders off the board with some 3D printed diffusing transparent or translucent material on one of her projects, which is cool. Lamore is still on the lookout for clear shafted encoders, which would shine the light right up through, which would be super cool. However, the other thing is that they are a lot slower to talk to because of it running over I2C versus these NeoPixels just on a regular digital pin. At least in my experience, I wasn't able to optimize that to my satisfaction. So getting higher tempos, BPM, out of this thing wasn't really possible when those lights underneath there were running. So there were a couple of reasons to go to these top-facing ones. Okay, so that is how those go. I'll leave a couple of these unscrewed just because you don't want to watch me screwing all those in. And now, the way I have this set up, printed it that way. The pixels, so this fits over here, hopefully, crossing fingers, yes. I can use the shaft screws on the encoders and the nuts that come with them. This may be a little dicey to also use the washer. It might not screw on more than like a half turn. Yeah, that's just a little, which is okay. I don't really care about using the washer in this case because I'm using pretty narrow knobs and they don't really cover that much. So I'm just going to go straight in like so. But before I do that, I want to screw in the NeoPixel strips. So pull that back off there, and let's screw those in from the top. This is a case where I wasn't thinking too much about it, and I went and replicated the PCB hole for every single hole that's on them in the top. I probably could get away with like just 2 on the end. This thing is not, you're never touching this. They're actually soldered together with little rigid pins, so they're not going anywhere. I may just put them on the end so that it's a little more attractive and we have fewer holes. So let's take, I think I'm using these longer ones like that, yeah. So longer M2.5, that went through that hole no problem. I probably already had done it once with that particular screw, so it's a little smushed in. The nylon is a little forgiving. So let's do another long screw up through here. Great. And there's a nut. Whoop, whoop, whoop. And I think I'll just leave it at that. So this will be a bare NeoPixel type of look, which I don't love, but for now. But eventually I will also laser cut or 3D print a little diffuser or just put some filter over that. So that is how that sandwich is on there. It's the basics. I may also do a sort of third section that is either 3D printable or slices of multiple sections of acrylic so that you could stack them in the sort of ice cream sandwich vanilla part of it here. But for now, it's more of like a front panel type of build. So these are just going to be attached using the nuts that come with those encoders. And again, I'll just put a few of them on right now. I'll skip every other one so that you're not watching me put those together for too long. Also, these screws on the top, if I can get away with using the laptop screws that are 2.5, M2.5, they may not. I'm not sure if they'll fit through that PCB or not, but they are super low profile, flat, which I like the look of better. Let's do one more of these. How about here? Good. And then I've got the knobs, and I'm going with we have these multicolor shaft knobs, and I decided to go with the classic Roland 808 color scheme per bar. So quarter notes in a bar, first note of the bar is red, second orange, third yellow, fourth creamy white. These have a little set screw, tiny little, what are you? Oh, this one's not marked. I don't know what you are, but it's a little Allen, tiny Allen screw. 00 or something. Is that how Allens are? I can't remember. With these, you want to be a little careful not to sink them too far down, or the push encoder won't work, because the knob might bump into something. So you've just got to test one before you... Yeah, that one's too high. Ooh, this one, I think okay, this is another... Gotcha. Get extras of these, because a few too many uses of that screw and it'll strip out the plastic. That one might be shot and I didn't bring extras. Okay, that one we won't be able to mute because that one's bottomed out. So that's just a little caution there. Don't take these on and off like I've been doing. That one might have been from another project too. Oh, click, click. I had some other knobs from another project I wanted to use that were nice old school, look like vintage guitar amp knobs, but the skirt on them was too big and these are pretty close together encoders, so this wouldn't work, sadly. I have a bag of 50 of those and I'm still looking for the right project for them. All right, so those will all click except for this first one. I think I've unscrewed and screwed that one too many times. That's not, so it'll still work, by the way, for rotation, but it's bottomed out for clicking on that particular one. So that is it. That's what the little build looks like, and then I'll put some little rubber feet. Oh yeah, that's coming right off. I'll put some rubber feet on there. Oh wait, is it? Why is it catching now? Why are you catching now? What's happening? Oh, because the whole set screw came out. Yeah, this thing is just so short and small, and it, I think, ate up some of that plastic there. Any chance? I might be able to shim it. Let's do that. I'm going to shim it with a little piece of zip tie. Let's see how that works. So I think it will screw in tightly up to a point, and then I think the second half of the threading just got chewed up. Let's see. Okay, that bit into the, yeah, that works. Okay, so that bit into that little piece of zip tie pretty well. Fun. That's the kind of stuff that someday someone will buy this thing at a garage sale and find the very weird little hack that the creator or fixer made. Okay, good. So there you go. Let's bring this over. Yeah, Mouse says knob selection is a difficult problem. It is. It is. It's a fun one, but okay. So now. Oh, by the way, just popped back over to my computer, and now I can see the YouTube chat. Dan Etchell says you can use Hilo Coils to fix that knob. So that's like a, is that like a little spring kind of wire that goes around the screw? Tell me more about that, because I've seen some stuff that's meant to like fix stripped screw threading that just kind of bumps out the screw a bit. Is that what you're referring to? I am curious. Okay, so let's take a look now at this in action. I'll show you how this works in concert with this thing a little bit. If I can fit it all on screen. My camera is semi-broken. It will not hold a position up here, so we may get... Hello? Oh, okay, it stopped moving there, so that'll be a slightly wonky angle, but at least you can see it all. So now we've got USB-C for the Cutiepie. So I'll plug that in here. By the way, this is also one of those conundrums always with this type of thing. Oh, let me turn the volume down for a second. Is where to put the USB-C cable, because you're going to bump into stuff. I like these little right angle cables. That works pretty well there. Okay, so you can see the LEDs fairly well. Move some stuff up. So yeah, so I showed this last week, but summarized, Blackbox is providing USB host data power to the Cutiepie. Cutiepie is just sending USB note on, note off messages. When it first boots up, it sends a MIDI panic, a couple of different MIDI panic versions to just clear out any notes, turns off all notes that were held, because it's very easy to turn this thing off while it has just turned on a note and not turned one off. So this is a ages-old conundrum in MIDI. So let's see, I can fit that there. That'll work. In our... I'm going to stop all these notes, so I'm just going to hold them all. Oh, except for you. Hey, what's up with that one? I wonder if that knob is also sunk down and it's not really... Well, that's mysterious. Hold on. I'm going to grab that little hex driver. Yeah, that note is not turning off, so I'm thinking... There it is. Okay. Yeah, that was not... that knob was on. Okay, how about you? Yeah, okay, so now all the notes are off, so we can turn the volume back up. I'll go to just a new preset. So that means no samples are loaded up in here. We could load up a piece of that Alexa thing for fun. How about that? So chaff. So I'm going to go load, look for alexawand.wave, yes. Load that. I'm going to chop or edit, trim is the word I'm looking for. That sample down to here. Play it just to test.
I'm having trouble understanding right now. I'm having trouble understanding right now.
I love that sample so much. Let's take a piece.
I'm having trouble understanding right now.
How about now?
Now.
Okay. Let's adjust that to be, instead of a trigger, a gate, so we can start and stop it. Which means we now have an envelope on it. And so I'm going to make a faster release. Okay. And sorry that's not super loud. I didn't plan on doing this, so I didn't hook up a mic. Mouse says, I'm having trouble understanding right now. So in the configuration for this, I'm going to tell it that it receives MIDI in from channel 1, which is what I happen to send this out on. So now if I enable one note, yeah, it's not going to be very loud. Let's see, can I boost the gain on that? Oh. Sure. Let's turn on, this will be very percussive. All right, so let's mute that, and I'm just going to change the style of that to be a trigger. How do I go? Configure. So instead of a gate, now they'll kind of play and overlap. Okay, so you get the idea with that. It's not a very musical example, so let's just bring in an actual sample of a note of some kind. I'm going to go up to Heinbach. You've a nice, oh, those are all loops. I want to, loop masters, load keys or string or synths. Oh, let me turn these off so we can preview those. Not these. Okay, let's do a keys. Let's see if we can get... Oh no, these are all... Maybe loop masters are not the ones I'm looking for. How about soundtrack loops, acoustic kit, bass, okay. These are a lot of drums. Moog kit. Nope. Oh, wait. Nope. Go up. Simple sound bundle. What was in that? House piano. Okay, good. So this is a multi-sample, so someone sampled every 3 notes, every 3rd note, so that you're not doing as much mangling of the sound to repitch it. I won't load this as a multi-sample because frankly I can't remember how, but let's pick something close to what our default is, which is 60. Okay, and then we'll do a gate on this. So we can use a little bit of an envelope. We will turn MIDI in, whoops, to channel 1 and do a quickish release. Okay, so now with this pad selected, and let me tell Alexa there to not be triggered by MIDI. Okay, so now if we get the idea. And one thing you may have noticed there is, and I mentioned this I think last night on Show and Tell, I had, one second, I had made the decision to only check one Stemma QT, I2C, Seesaw, encoder, and button set per bar. So rather than always asking both of these what they're up to, I wait, I believe, till I play the last note before I get here. So when I think, or no, here. So when 4 gets read, I'm reading the whole thing, and when 8 gets read, I'm reading this set of 4. So when that passes, this set of 4, that. So it's half the transaction. It's just a faster transaction to read those, which means that I give up a little bit of the performance speed, so I can't instantly get changes. I have to kind of wait for that bar to come back in there. I might be able to make that a little faster by reading right before I get to it rather than right after the last one, I'm realizing. But so that means if you watch, when I turn on this note, it waits to get there. So I had to pass this white knob before anything in this front section gets read. Change it. If I change this before, let me turn these two off. If I change this knob before I get to that white knob, we'll hear the change on the next loop. I missed it that second time. And off. So that's the main caveat on that, just to keep it CircuitPython able to read those quickly enough and not slow the thing down. So I think that's all I want to show in that. And then the last thing I'll do is I'm gonna just show you the model real quick over here. So this is these excellent Ruiz Brothers. By the way, I'm so sorry, I still haven't taken the time to figure out where I set these really fat, thick lines on this. I don't use this machine for Rhino. It's just my broadcasting machine. A few years ago, I set these thick lines, and I have not found where to fix it. I need to take the time to do that. So it's a little bit of a bloated looking wireframe, especially these. Those are the meshes that I export right before 3D printing. These are the NURBS models that I output with trims from the process. So I'm keeping them 2D. So if you look at these just from the top, that's all just laser cuttable or drillable, hand toolsable, printed on a laser printer and glue it to something and cut it. It'll be straightforward that way. But I just did all of that by inferencing my holes from these models right here, and we have a accurate PCB NeoPixel stick. These very nice quad encoders. They're all up on the GitHub, Adafruit CAD GitHub. Cutiepie, RP2040 there, and then I only found an STL model for this this little holder here, but that works just fine. And so hopefully I'll be able to stack 2 of those together and either print them separately. If it's on a printer, on a laser cutter, I've got plenty of room to just laser cut the whole thing. So I'll give you a couple options on those, but I'm going to expand this out to the 16 knobs. All right, I think that's going to do it. So did I forget anything? No, I think we're good. So that's the next project. I'll be finishing that up soon, writing that up, and I apologize. Someone asked a couple questions I didn't get to. I was not planning on live coding today since I was live building, but maybe I'll do some more in the future if that's interesting to people. Quinman16 asked, do the Ruiz brothers have a 3D model for the Stemma QT I2C Wii to Nunchuck adapter? I don't know, but I'm happy to show you how I would answer that question, which is head over to github.com/Adafruit. And in the Finder repository, type in CAD. Adafruit CAD parts comes up first, and then you can either click on one thing, and it seems, I don't understand this interface. If my screen is a little wider, it'll bring up a little navigator. I don't know how to bring that up other than clicking on something, but once you do, you can then type in Wii. So there's Wii nunchuck adapter. I can click the folder, and that'll show me the files. Again, my window is a little narrow, so we weren't seeing the file extensions, but here's a step file, and here's an STL file. So I would grab a step from that. I click it, and then click download, and it'll download the raw file. And then if I come back over to Rhino here, I can bring in that step file into my scene here. I'll say import file. I'll agree to some things it's going to ask me. Yes, import. Yes, import. There's the file. Oh, go away, side thing. And there you go. There's your Wii adapter, Quinman 16. Do a nice little render of it. Beep. There you go. And I trust the Ruiz brothers, so you're good to base your measurements on that for whatever you're building, case for it, otherboard, and so on. Hey, Sonny. Hey, John. It's Sonathan from Resistor NYC. Hello. Thanks for popping into the chat as well. Anyone else who jumped in? No? Okay. Good. Thanks. Hey, I should wrap this thing up. Thank you. Eliteness 3000 said, yeah, automatic gain control was AGC. I can't remember what I made up. Maybe that. Maybe I didn't. Thank you for the confirmation. So there you go. That's a nice, actually the render is so fast on this machine, and it looks a lot better than that shaded view. This little ambient occlusion action. Good gracious. So there you go. That is that. And I'll wrap that up. So thank you, Yanisku7, for bringing Yoda into the chat. What's Yoda up to? Okay, that's going to do it. I'm John Park. This has been my workshop. You've been here. I appreciate you. Thanks for hanging out. Oh, Badagraph Abdelhagen, I said compensation. Automatic gain control, not gain compensation. I got threw fancy word in there. All right, what's going on? I believe we've got our favorite foamy guy tomorrow. Tim is going to be doing a deep dive. And then over the weekend, there should be various musings from Phil and Lamore as the desk of Lady Ada and other videos emerge. So keep your eyes peeled for that. I'll be back on Tuesday with a product pick of the week. You won't want to miss it. And then Wednesday morning, 3D Hangout, followed by, right here in this slot, Show and Tell. And then just after that, Ask an Engineer. And more. Thanks, everyone. Have a good one. For Adafruit Industries, I'm John Park. This has been John Park's Workshop. And now we'll listen to Alexa.